Hello and welcome to the Graphing with Rational Transformations video. In our last video, we spent a lot of time looking at features of rational graphs, but now we're going to take some time and actually graph them. And in order to do that, I first want to take a look at the parent function of a rational function, which is 1 over x. So some features about this is we'll notice there's no k value moving us up or down, there's no h value moving us side to side. So this means that my vertical asymptote is x is equal to 0, and my horizontal asymptote is y is equal to 0. Now just a reminder, asymptotes are lines that we cannot cross, and we denote these on a graph with dashed lines. So my vertical asymptote running up and down at x is equal to 0 will look something like this, and my horizontal asymptote at y is equal to 0 will look something like this. So these are boundaries that we cannot cross. So if I wanted to graph this parent function, I have my x and my y value. We usually do -2, -1, 0, 1, and 2. However, we cannot use 0 as an x value because that's where our asymptote is. It's a line we cannot cross. So instead we get a little bit closer and we do -1/2, and +1/2, 1 and 2. So we get really close to those values, but maybe not quite. And then we take a moment and we plug these x values into this function. So if we did -2 in here, it'd be 1 over -2, or -1/2. If I plugged in a -1, I'd have 1 over -1, which is just -1. If I took a -1/2 and plugged it into this function, I'd have 1 over -1/2, and 1 over a fraction flips the fraction. So instead of 1 over 2, it'll be 2 over 1, or a y value of -2. If I plug in a +1/2, 1 over 1/2 will flip that fraction to 2 over 1, or a +2. If I plug in a 1, I get 1 over 1, or 1. If I plug in a 2, I get 1 over 2, or 1/2. So when I plot these points, let's see again, that's -2, -1/2, -1, 1, -1/2, -2. And then we have 1/2, 2, 1, 1, and 2, 1/2. Now you notice that this is in two different quadrants of the graph. We're not going to connect the quadrants because the asymptotes are lines we cannot cross. So instead, we get something that looks like this. So make sure that you're extending your graph all the way through from one end to the other, and we get really close to those asymptotes, but not quite. So this is a rational function. Now we want to spend some time moving this up and down, side to side, reflecting, or stretching. So we're going to go back to the problems that we were using in our previous video, and I'm just going to write down some important information for us. So for problem number 5, just a reminder that function was f of x is equal to -2 over x plus 1. Oh, pardon me, x plus 3, there we go, minus 1. We had that the vertical asymptote was x is equal to -3. We had the horizontal asymptote was y is equal to -1. We had that the x-intercept was -5, 0, and we had that our y-intercept was 0, -1, and 2/3. So this is all the important information. We'll graph that in a moment, but first I want to just look at this problem and go, what are my transformations here? So when we take a look at our transformations, I go, okay, at first I see this negative out in front. It's with this a value, right? So remember, the a value stretches our function. So this negative means that there's a reflection, specifically over the x-axis. And that 2 means there's a stretch up on top. So it's a stretch by 2. Next, down here, I see that we have something happening horizontally. This is a horizontal shift. Since that's a +3, it means we're going to be moving to the left 3 units, and that -1 at the very end means we're going to be moving down 1 unit. So if I was to make a table here, a transformation table, which we've practiced before, I'm going to start with my x and my y value, and I'm going to use that parent function that we had above. So remember the x values for that are -2, -1, -1/2, 1/2, 1, and 2. I didn't make mine long enough. And the y values were -1/2, -1, -2, +2, 1, and 1/2. This is the parent function, but now let's go through and apply our transformations. Well, when I think about my transformations, I see that moving to the left 3, that's the only thing that happens to my x values. So when I take a look at my x values, I'm going to subtract 3 from all of these, so remember to flip that sign. Let's see, -2 minus 3 is -5. Then we'll have -4. Then we'll have negative, you can write -3 and 1/2 or -3.5 if you want. So for instance, if I do 1/2 minus 3, that I can write that as -2.5. That's okay to do. And then we'll have -2 and -1. These are our new x values. And then for our y values, we have 3 things going on. I'll make this kind of big. First, we have a reflection. So that means we're multiplying by -1. Then we have a stretch by 2. So I'm multiplying by 2. And then lastly, we're moving down 1. So I'm actually subtracting 1. So when I multiply everything by -1, I just flip the sign. So that's 1/2, 1, 2, -2, -1, -1/2. And then I'm going to multiply all of my y values by 2, which will be kind of nice because then we won't have any more fractions. So let's see, that'll be 1, 2, 4, -4, -2, and -1. Lastly, I'm going to subtract 1 from everything, and we'll have 0, 1, 3, -5, -3, and -2. And these will be our new y values. And I can see that I've done this correctly because in one of our features, we found that we have an x-intercept at -5, 0, and I see that I have the point -5, 0. So I know we've done this correctly. So again, last video we found our features. Here's our list of transformations. Here's the transformation table. Lastly, let's graph. It's going to take me a moment to do this, so I'm going to pause the recording and it'll just show up. Okay, so we have our graph. So now if we take a look here, first thing I'm going to do is I'm actually, instead of doing the table first, I'm going to mark in this information. So remember, we do our vertical asymptote and our horizontal asymptote with dashed lines. So when x is equal to -3, that's a vertical asymptote going this way, and a horizontal asymptote as y is equal to -1 is down here. So we can see those are kind of our boundaries here we cannot cross. I also want to make sure that our intercepts are graphed. So we'll have -5, 0. That'll be right here. And we'll have 0, -1 2/3. So I just know, I'm not going to be able to tell the difference with my human eyeballs between -1 and 1/2 and -1 2/3. So I just know it's supposed to be closer to -2 than -1. So I'm going to say that's good. I'm going to say that's about right. So from there, I'm going to graph the rest of the points that we know. So let's see, we have -5, 0, which we already have. -4, 1, which is here. And let's see, -3.5 and 3, which is here. So we have a graph that looks something like this. And then for our second section, we'll have -2.5 and -5. So that'll be there. We'll have -2, -3, and -1, -2. So remember, don't just do that. I want to see more than that. I want to see you go from one end of the graph to the other, get really close to that asymptote. You may notice that this is in different parts or quadrants than the parent graph. Remember, the parent graph was up here and down here. But remember, we reflected, so it's switched. So we have this section here and this section here. So hopefully that wasn't too bad. Once you have your features and your table, go through and graph. Let's try just one more function. So just like last video, we have problem number 7. So I'm going to move this up just a little bit. Let's see, problem number 7, that was f of x is equal to 4 over x plus 1 plus 2. We have that the vertical asymptote was x is equal to -1. The horizontal asymptote was y is equal to 2. The x-intercept was -3, 0. And the y-intercept was 0, -6. So there's all the information we have for right now. If you wanted to graph this right away, you can. But first, I'm going to list my transformations. So similarly to what I did before, I'll take a look at my a value. There's no negative here, so there's not a reflection, but there's a really big stretch. It's going to be a stretch by 4. Then I can see that in the denominator, we're moving over 1. So we have a shift to the left 1 unit. And then our k value this time is positive, so now we're going to be moving up 2 units. To make a transformation table, I'm going to stick with the same parent table that we did before. So we're still going from -2 to 2, but instead of doing 0, we're going to have a -1/2 and a +1/2. And our y values are -1/2, -1, -2, 2, 1, and 1/2. Taking a look here, I'm always going to start with my x values, so anything moving left or right. So for my transformation table, I'm going to subtract 1, flip that sign. When I subtract 1 from all these values, I get -3, -2, and you can write -1 and 1/2 or -1.5. -1/2, that looks a little weird, so I'm going to make that a little cleaner. -1/2, or again, -0.5, that's okay. 0 and 1. So that's all of my new x values. For my y values, we have 2 things going on. First, we have our stretch, or we're multiplying everything by 4, so really big. And then since we're moving up, we're going to add 2 to everything. So when I multiply everything by 4, -1/2 times 4 gives us a -2, and a -4, and then a -8. Oops, that's a weird looking 8. You know, we're just gonna having a rough time writing today. All right, -8, there we go. And then we'll have a +8. Ooh, much better. 4 and 2. Lastly, when I add 2 to everything, I'm gonna have 0, -2, -. Oops, sorry, I just muted myself. I'm just filling out the table. 6 and 4, and this is our new y values. And we can see that we have the point 0, 6 as a y-intercept. And we have, oh, I'm so sorry, I'm just realizing that in our last video we found that the y-intercept was +6, not -6, my bad. But again, you know, I used that to double check myself, I think, which was really good. And we can also see that we have our x-intercept at -3, 0. So now that we have our table, I'm going to pause this video to bring up a blank graph. So here we have our graph. Again, just like last time, first I'm going to mark in my asymptotes. So we have a vertical asymptote moving up and down when x is equal to -1, right here, and a horizontal asymptote when y is equal to 2. So up here. And I want to make sure to plot in my intercepts. So we have one at -3, 0, and we have one at 0, 6, all the way up here. So now I'm going to plot in the rest of my points. So I see we have -3, 6, or pardon me, -3, 0, which we already did. We have -2, -2, which will be here. And we have -1/2 and -6, which is all the way down here. So again, do more than just that. I want to see more than that. I want to see you go all the way from one end of the graph to the other, getting really close to the asymptote, but don't cross it. When we do our next set of points, we have -1/2, 10, which goes a bit off this graph, so like there-ish. We have 0, 6, which we already have, and 1, 4. Can we graph it? It looks something like this. Get really close to our asymptotes. So there you have it. We have officially gone through 2 full problems over the last 2 videos. You're only going to have a few questions to do on the Go-formative because I know these take a while. Please let me know if you have any questions. I look forward to seeing you during class.